Okay, guys. Oh, you can hear me. So, welcome. Did you miss me? Um, Sorry for being away this week. It was a week full of some conference and stuff. So, today we're gonna have the probably the last lecture together, and I'm gonna combine it in. I'm gonna have two parts, basically combining. The first part is gonna be about LaTeX and a small introduction to it, and the second part is gonna be the things that we haven't concluded in Git yet. So we are going to learn how to write things in LaTeX, and in the second part, we're going to practice probably with how this is going to work with Git and how you can push and pull to GitHub, which eventually means that you should know how to do anything required um, for your assignment, which I think is due the week after. So you should have enough time. We will also have, like Clara said, we'll have a session on Wednesday where we can assist you. We did that last Thursday as well. I mean, not yesterday, the week before. So, yeah, any further questions, we can solve them then. So let's go quickly because we don't have enough time. I'm a bit rusty, so okay, that should be good enough. Of course, again, you can ask me any questions and stuff. I sent you a link about how to download LaTeX in your computer, and I'm gonna quickly skip to this part where I send you how you can install it locally. So if you don't have enough time or your internet is not fast enough to download it now while we are at least going through the basic theory, it's fine. We have an option to work with LaTeX online. But please, while we're doing the first part, download a distribution of LaTeX, whatever it means. So I sent a link in the Discord chat about how you can download it. The first distribution, MikTeX, you can download it for operating systems. If you are on Mac OS, you can use MacTeX. And on Linux, you can use Text Live. I guess if you are on Linux, you know how to do so. We might have to troubleshoot in the process, but that's okay. Also, you need to download an editor. So you can go to Text Studio for Text Studio or TextMaker. I used to use Text Studio, but actually you might not need an editor necessarily because you can also use Visual Studio Code as well. So Guillermo asks if we have to download it in the C drive. No, it doesn't. It shouldn't matter where you install it. Okay, and the editor should be clever enough also to find out how to where it is installed and do what it needs to be done. Okay. Yeah. So as Clara says, do as you find more appropriate. Okay. So has anyone worked with LaTeX before? You might say yes or no. Do I have that much latency? No. Good. Okay. No. I'm gonna go ahead while you type. That's okay. It's just it doesn't change much. Okay. One has used overlay. Okay. No. So many no's. Yeah, anything would work, Constantinos, but I'm gonna show you in Visual Studio Code. I have Text Studio as well. Sometimes you have to play it around. We're gonna see it in practice. We're gonna go quickly in practice. We don't have much of theory today. We're also going to try to skip theory because I'm not sure if it works that much. I'm gonna go through Overleaf anyway and explain something. So let's go quickly. As I said, we don't have much time. So the first part is going to be about LaTeX, then we're going to go back to Git with LaTeX maybe. Okay, so I'm going to start with something basic, and it's something about changing your mindset. So when you use Word or I don't know if you use OpenOffice, LibreOffice Writer, or whatever you might use on Mac, they have their own suite. Um, are you using the bolds and italics and stuff to format your headers, etc.? Well, don't answer that. But if you do so, please stop doing so. Okay? So if you use those buttons too much, this is bad. Okay, you should use those only to denote like individual words as bold or italics or things like that. But you shouldn't use it to format headers, etc. Okay, and you should be using styles. I hope you do, and if you do so, that's already progress. Um, but why is that important? It's important because actually when you use styles, you start thinking more of the structure of your document and less of how it looks, right? Because you have styles, you have heading one, heading two, heading three, etc. And well, you can quickly write your text. You can set up heading one, heading two, heading three, and at any point in time, you can go back and say, okay, heading one maybe should be a different color, it should be bold or anything, etc. Right? So the important thing here is that you should start thinking more about the fact that when you're writing a document, there's the content and there's the styling, and those two things are different, right? And the only matching point is how you tag something. So when you tag something as heading one, content-wise, that's heading one. You don't care about anything else. You don't care if it's blue, you don't care if it's big, you don't care about if it's bold or anything. You only care that it's a heading and it says a title. And then, of course, there's a styling, and you can change the styling. You can say heading ones could be this color, etc., etc., etc. Okay, that's important for LaTeX because with LaTeX we focus on content. The idea is more that someone gives you a template, or you are interested more in focusing in the content and the structure of your content. So sections, subsections, chapters, etc. And you don't care about them while you're writing the document. That's the important difference. So this is like a new approach. It's not about how it looks, it's more about what it is. What are the contexts? Okay. And you just write the content, you define what's a section, you define what's a chapter, and then you let LaTeX do its job. And what's different than what you've seen before probably is that this is some kind of a source code thing. It's like writing a Python script. You write the script, you run it, and then you get the outcome. And it's the same with LaTeX. You write LaTeX code, you let the LaTeX engine compile it, and then you get back a PDF. That's how it works. You don't really change the actual content as you edit. That's different than Word or Writer or anything. And well, it might seem difficult at the beginning, but there's a benefit about that. That, as I said before, you don't really care when you write about the colors, right? This is kind of a distraction. So with LaTeX, you focus only on what you write and the structure of what you write. So let's start with a simple example, and that's it basically. This is LaTeX code, okay, and you have this thing with a backslash, and then you define parts. You have curly brackets to say, to give arguments to this thing, this part, which is basically a command. And then you want to have text, you just write the text inside. Lars has a question. No. Good. So, I'm going to go through each one of those. I told you already how to install it. Um, okay. Uh, I don't know about that. So, are you installing it now, guys? Has anyone installed it yet? Okay, all the student 8028. By the way, it would be helpful if I knew your name. But no, I don't know the password to install MikTeX on Ubuntu. It should be your password. So the password of your user. Okay, everyone seems to have installed it. So if you want to work with Text Studio, and so like it's a dedicated editor for LaTeX, I used to use it. That's the interface, more or less. I changed it to be in dark mode, but it doesn't really matter. And then you can make a new document and start basically writing LaTeX there. But you can also use Visual Studio Code for that purpose. Okay, so I'm gonna show you. We can open a new folder. I guess we can make something like a LaTeX test. You can make a folder anywhere you want. Okay, and then I suggest that you go to the extension store on the left. I think I'm gonna make it. I'm gonna have to make it bigger. Hopefully that's good enough. Let me know if you don't see it clear. And then you're gonna look for LaTeX, and there should be this plugin which is called LaTeX Workshop. And that's to do the trick. So you have a distribution, and the distribution has the engine that we said before, right? So the thing that actually takes your code and builds a PDF. And with Visual Studio Code, you can do LaTeX editing by installing this plugin. So you have two options. Do as you please. You either install LaTeX Workshop on Visual Studio Code and use that one, or you use Text Studio. The third option that I said before, if you haven't had time to install it yet, is that you can use Overleaf, which is an online thing. It's an interface where you don't have to install anything, and you can just start typing there your LaTeX code, and it's going to compile and everything for you and give you back the PDF. I don't necessarily suggest to use it because, first of all, after a while, it's going to ask you to pay. And second of all, it's kind of annoying when your document grows and you have dependencies like images and stuff. So that's a bit annoying. Okay. So, but if you don't have, if you didn't have enough time to do so already to install the thing locally, or if something is broken and you cannot follow along, and based on the fact that you don't have enough time, you can go there and I think you can directly just log in with your Google account or Twitter or whatever, and then you can quickly start doing some things, at least for practice for now. Okay, I think I'm going to use Visual Studio Code. That's what I use lately, although sometimes things are not that good. Okay, so I'm going to make a new document, which I'm going to call test.text. Sorry, text. Okay, tech, I don't know what's the right way to pronounce it, is the de facto suffix for LaTeX documents. Okay, so if you save your file as a text, so if you make a new text file or if you open a text file, then you will see that on the left, as soon as you have installed the workshop, you will get this tab, which is basically the things you can do with LaTeX from Visual Studio Code. Okay. So let's start by playing with the simple example that we had before, and it's this one. I'm gonna copy paste that, and I'm gonna actually also send it to you guys. So you might also want to copy paste it instead of typing it all together. And there it is. Right, so Visual Studio Code is also clever enough to give us this highlighting. I hope that works for you as well. You also get this tab here and you also get some highlighting. If your file is not recognized as LaTeX, you can also go at the bottom right. Done. Don't do this now. And just change it from here. You can set up something as LaTeX or just text. Okay. So I see no people raising any questions, so I guess you got it working. Now, hopefully, Visual Studio Code identified that you have installed the your um, your text distribution. So if you go to build LaTeX, you have certain recipes. I don't want to go into detail about what that means, but I would suggest that you use this one, PDF LaTeX, BibTeX, and PDF LaTeX by 2. Guillermo is getting an error. I'm going to click on that. Didn't work. So yeah, okay. Don't use the LaTeX MK. Use the recipe that says PDF LaTeX, BibTeX, PDF LaTeX by 2. And let me know if that works for you. If you do the double click, you should see this on the bottom that it's working. It complains that there is an error, but actually there isn't as far as I checked. It's complaining about missing citation and stuff. That's fine by now. Okay, Luis, that's fine. So if you have Windows, uh, Lisa, I suggest, I assume you also have the same with Luis. So if you get that, just press install. You're going to get these occasionally. I'm going to explain soon what that is. Okay? If you get a pop-up, just press install, don't press cancel. So Guillermo, I guess you refer to Visual Studio Code. You wanna send us a screenshot, maybe of Visual Studio Code? Okay, doesn't look that bad. I think you can see the colors. Uh, yeah, as I said, you should go to the Tech tab and select the recipe which says PDF LaTeX. Did you do so? Um, I don't get what you mean. Okay, Guillermo, could you just expand build LaTeX project and go here where it says PDF LaTeX, BibTeX, PDF LaTeX by 2. It should be this one. Is there or not? If yes, then you should double click this one and you should get a different thing because what you get now is from the first recipe and we're not using this one. Okay, that's weird. Um, okay, then can you just download Text Studio and try to make it work from you there? I'm looking into it. Okay, I guess it didn't. I guess it didn't recognize. So you have installed MikTeX, and you still get that. Is there anyone that it gets either Louis' message or it worked for them? I mean, actually, to make sure that it works, you should actually, if you look at the files, you should get a PDF now, and you can just open it. Or you should get this little thing at the top, and basically, if you click on that, you would get a PDF open. And all that it would say is a hello world. Louis, that's fine. Just install everything that is being asked. Are you, Louis, on Windows and are you using Visual Studio Code? Okay, for those that get the same problem with Guillermo, the Spawn PDF LaTeX InnoEnt, did you have Visual Studio Code open while you were installing the LaTeX? I mean, maybe reinstalling Visual Studio Code would work for you. Sorry, closing and opening Visual Studio Code again would work for you. Uh, Lisa, you're getting a different thing. I think if you just go there and just press enter or something to leave an end or something, maybe the endpoint is not working. So there's a character at the end of every line, and maybe that's broken because I see it's also highlighted as an issue. So you should maybe that would work for you. Okay, Guillermo closed, open. Okay, closed and open Visual Studio Code, and now it's fine. Perfect. Yeah, as you see, it also complains with me. If I press that, I also get like there's an error, it says, which is annoying, but actually there isn't. It says that there's no citation and no bib information. That's because we don't have any bibliography there. That's why it complains. But the PDF should be there. If you have this icon, you should click on it and then you should get a PDF, which says Hello World. So if you have a PDF, you can either look at it through this icon, or if you check the content of your folder, there is actually PDF there, which you can open. And in that case, it means it worked. Okay, forget about the error. That's annoying, I know, but there's nothing wrong actually. Yeah, Jasper, you can just you can go in the folder yourself, so you can reveal it in Finder or Windows Explorer, whatever, and then you can just open it by double clicking. It's the same thing. Actually, here you can also, you should have this View LaTeX PDF tab, so you can say either that, View as a tab, or in web browser or in external viewer would just open it as a whatever, Adobe Acrobat or whatever you might be using for reading PDFs. Yes, if you are on Mac OS, maybe you should better install MacTeX. That's what I personally use. But MikTeX is also available for that. Not sure what's supposed to be better. Okay, Caroline, you don't have a PDF, but you get this error. Okay, we're gonna see about that. The version, but the PDF extension is PDF, so Luis doesn't have a PDF as well. No, an overleaf kind of interface is more like Text Studio. So if you want to have this thing where you can go from one side to another, Text Studio does that for you. So maybe it's easier if you use that one. So I'm gonna go here. I'm gonna have to go to temp. I have to go to temp, LaTeX text, and then I can open the text file. And if I press that, then I get this on the side. And then, but if you have a big file, you can actually go to source from the PDF and the other way around. So maybe Text Studio might work better for some of you guys. Okay, guys, if you get this issue where you don't get a PDF, you might gonna give a try to Text Studio instead. Maybe that would be easier for you. I thought we could avoid having a different editor, also because mine is a bit messed up. But let's go down that route, okay? Notje asks, what's the difference between the two arrows and the one arrow? This one and this one. Well, you should use this one, so the two arrows. And I'm gonna kind of explain soon, not now. So basically, this one actually runs a LaTeX many times because it needs so. But we're gonna go through this soon. I have to make this bigger. I guess also here. So just not to waste time with Visual Studio Code. If it doesn't work for you, try to do it with Text Studio and let's hope it works. So meanwhile, allow me to explain what this is. I'm going to do it in Visual Studio Code because I think it's slightly more clear. Let's close these things. Okay, so that's the tech code. And basically we have something very basic. So the first thing is a command. So every backslash defines that we're going to have a command. This is the name of the command. And then we have the curly brackets and that gives us the arguments to this command. The first command we always have to do, and it should always be the first command, is to define the document class. So a class is like a template, and LaTeX comes with some pre-installed templates. But if you are going to do any publications, or for instance, for your master thesis, we provide you with a template. And in that case, we give you some files, which you should have next to your tech file, and you should provide the corresponding text there. Luis, you have a, this is not the code that I'm showing here, right? There's something before the begin statement, which shouldn't be there. So your line number 3 is broken. That's probably also why Visual Studio Code wasn't working. Remove that part that Clara says. So we have the absolute basic LaTeX code that can exist. And the first line that we did is, as I said, we defined the document class. And in that case, we say that this is a simple article. That means just a plain thing, maybe with some title and everything. And this part here is called the preamble. Is things we can set for the document itself, like the title, some metadata, information about the author stuff. Here we don't set anything because it is the absolute basic. But basically, all we said that this is an article. And then we have those begin end statements, which are called environments. What? That doesn't sound right. You should delete that, save the file, and press the 2 clicks, the 2 arrows. See, it doesn't add anything for me. Are you sure you're pressing the right thing? Build and view. Don't go with any shortcuts or anything, because that might be that you're adding things from here or here. They have those commands. Not even sure what text address is. It's a slanted. So are you pressing Command Shift and S? Don't do so. Just press this actually. You don't even have to save because TextStudio is clever enough and it's gonna save for you. Luis. I hope that fixed it. So let's go again. First line we say this is a document of type article. We have some other ones. We can have like a real book with chapter and stuff. But an article expects that you only have sections, subsections, and it should be like for something that is a short report or something like that. You can find templates for having presentation and stuff. But this is just an article. And then we have this begin and end statement. And what it says is that we begin and end the document itself. So in between those things, we put the actual content of the document. So the actual text of it. And in that case, this is just a hello world, right? That's all the text that we have. And this is some comments. So this is the symbol for comments, the percentage symbol. Okay. That's weird. Yeah, if you install MikTeX, you can also try with TextWorks because it comes with it. Probably it's configured, so maybe you give that a try as well. Worst case scenario, try to go to Overleaf and do it with Overleaf. Okay. I'm sorry, this is like, it's kind of messy to install the whole thing. So it's understandable that it's annoying. But for now, you can do that and then we can troubleshoot more on Wednesday. But since we don't have that much time, try TextWorks because it comes with a thing. Hopefully that will work. Sorry for the LaTeX drama. And let's see what Clara says. Yeah, is it working for anyone else? Text Studio, whatever. I hope you can follow that. Otherwise, yes, let's do something in the break for Luis. Okay, so that's the code. As I said before, I'm gonna build it again. I'm using the shortcut here. Sorry. So I'm gonna build it again, and what I get, as I said before, you can go in Visual Studio Code. You can just see from here, or in Text Studio, it immediately shows itself next to it, and you get this document which says hello world. Okay, the basic idea so far is that we understand how commands are structured. So you have this backslash and then the name of command, the color scheme is I'm not sure. I'm going to go to Visual Studio Code. So you have the backslash, the name of the command, and then you have curly brackets, mostly, to define the arguments of a command. What are those commands? You normally find them as you need to do something. Okay. The absolute basic is you need to start by defining that class. Most probably it's going to be an article, and then you have these begin and end statements for the document. Those are actually called environments. Now let's go back to the presentation, and I think I have a much more interesting example which you can find here. And if you, I'm going to copy that and paste it here instead. And I need to end it like this. It's kind of messy. Sorry about that. I'm going to write it and send it to you guys. Okay. So that should work. I'm going to take it from here. You can either start typing it, or I will send it to Discord. It might be better if you just type it, but anyways. So now you see at this PDF, this is slightly more interesting, right? I'm going to sort side by side. So I don't know how intimidating that is, but basically that's a complete article, okay? So we start by defining the class and saying this is an article, and then we define, before the actual content, we define the title, which in this case is the title, and the author, which is John Doe in that case. See, this is a command, this is the argument. So we say the title of this thing is a title. The author of this thing is John Doe. Then we start the document itself. So this is where we actually ask LaTeX to print things in the PDF, let's say. And then we give one command which is called make title. And in that case, what LaTeX does is like, oh, I'm going to take the title, the author, and the date, and I'm going to print it in PDF in a specific style. Okay. So that's what it does. That's actually the part that is printed with the make title command. That is done for you. You don't have to care about that. If that, if the class of this document was a book, then the whole thing would have been made in its own page, and LaTeX would have taken care about that for you. So that's the good thing that I said about LaTeX before. It gives you the privilege of focusing to the content, and the styling is all done based on some template that is defined beforehand. And this is common sense. Normally what you do, you define a title, you define an author, and then you normally ask to make a title, more often than not. And someone else had decided before you, based on the template, how that should be done. Now then we define a section, and we give the title of a section, which is exactly the same thing as typing this is a section, and then styling it with a heading 1 style in Word. Right? So you define the section, the title of the section, and then you just type in the content of that section. That whole thing is done automatically. So this is the content of that section. So you see what happens here? That this title is actually formatted and numbered accordingly because you defined it as such. And then the content below it, some text here, goes actually there. Then you can go even further and define subsections inside the section, and you can use the subsection command for that. And again, you provide the title of the subsection, and this is going to be formatted and numbered accordingly. The same goes on and on and on. Are there any questions so far? Guilherme has one. And Caroline. Okay, Caroline, you want to send us a screenshot? So Guilherme asks something that is far further down the road. So what's the default reference structure? Well, there's no default one as far as I know. Every different publication. Can you show us the source code as well? There's something wrong with the source code currently. So Guilherme, yeah, every different publication um, office will ask you for a specific one, and they will probably just provide you with a template which takes care of that, and then you just put your bibliography there, and it does it for you. Yeah, but there's still something wrong. Can we see it? How can we see how it is in your text works or whatever you're using? I just want to make sure that not everything is in the same line. Oh, that's really weird. Okay, Caroline, this should be something really broken there. So we can look at it during the break, okay, as well, because we don't have enough time now. That's weird. One thing you can try is maybe just, you can do that occasionally anyway, just press the double click the cleanup auxiliary files first, and then try the recipe. Are you using the PDF LaTeX? Whatever you're using, you can just try to clean it up first. Okay, so before we go to the break and assist Caroline and Luis with their problem, one last thing. So far, what we've learned is that we have individual commands, and we have this thing, which is the begin and end thing, which is basically an environment, right? So sometimes it's actually helpful if you intend your document in such a case, and you can even do so with sections and subsections. Personally, I don't do that, but I'm saying you could have done that. Now, why is that? Okay, perfect. Caroline fixed it with a simple cleanup. Once in a while, you might need to do so because in the process of compiling stuff, the LaTeX creates some intermediate files, and then yeah, that happens. That might have also fixed this problem. Anyway, so you can do an indentation if it helps you because it gives you a better understanding of the structure, but that's not always necessary, especially not for the begin and end document. We're going to see some more environmental and some more environments because this is the document, the absolute basic one. But basically, you can think of them like single commands like title, author, make title, section, and stuff. They don't begin and end specifically somewhere. And you have this begin and end command, which basically creates and stops an environment. That's the basic thing. And one last thing that I think it might be kind of new to you, is that you saw how I could actually tab, or even if I allow many white spaces here, if I compile this one, it's actually compiled by default. So this is now compiled with the new code, and you see that still there are no changes to guess what. It wasn't updated based on all the tabs that I had before. Those white spaces were also ignored. It only allows for one white space, which is kind of cool. One of the things that many times Word documents might be suffering is like two white spaces and things like that. And this is this is how LaTeX works. It's gonna ignore all the things that could break your document. And you notice also something weird, which is kind of similar to that one, that even though guess what, and this is another piece of information, those two lines, they are written in different lines in the code. They're actually the same paragraph. You cannot see it here, but I could say, let's write something else that is long enough. And I'm going to compile it, and you see that this is a whole paragraph of its own. Now, how do you go to another paragraph? You need to actually leave an empty line in between those things, which is actually kind of cool because it allows you to write things in such a way that every individual sentence is in one line, and it's kind of more clear to read and fix issues that way, or at least to me. It's also useful when you combine LaTeX with Git, because that way Git can be more aware of your changes. By the way, apologies for my dog barking. And it's more useful for when you are using LaTeX with Git, because it can better find out the differences between the files, and if you have every sentence in its own line. And I think it's also more clean because it doesn't go too long and everything. So this is another example. Uh, let's say this is another paragraph. I'm going to compile this one so you see. And you see that I got another paragraph. And you see again, the whole styling is being done for us. So in that case, that specific template, the first paragraph doesn't get any indentation in the first line, but the second one does. If I kept writing here, I'm gonna keep writing until the second paragraph gets a second line. I'm gonna compile this one so that you see that this is just an indentation of the first line of the second paragraph. Sorry. So you see what's happening here. The whole styling is decided for us. The first paragraph doesn't have an indentation. Every individual paragraph from then on does have one. Let's do a 10 minutes break. So we're going to be back quarter to 12. And we're going to sum up on those. Quickly go to some more things you can do with LaTeX. And then we're going to combine LaTeX and Git together. Okay? So see you in 10 minutes. And let's go help Luis. Okay, guys, should I leave that here? So sorry for the late thing. We were trying to help Luis with her problem, and we figured out that actually, if you have a Mac OS, it's better that you install MacTech instead. So if it works for you, that's fine. But if you get any issues here and there, I think it's better that you use MacTech. Okay. So this is at the end of this page that I just sent. The instruction about how to remove MacTech. Those three steps that you need to run with the terminal. If you need any help, we can deal with that either after the course or after the lecture. Yeah, so just a couple of questions. Runan says it doesn't update synchronously. No, it's normal that it doesn't. For me, Visual Studio Code, when I save, it just compiles everything. In theory, you should just press the compile button, whatever is your interface. If that's uh, if that's Text Studio, those two arrows, is that Visual Studio Code on the left, but Visual Studio Code, when you save, normally does it for you. Using Gene asks if it can automatically show changes in PDF. That's a very interesting question, actually. So that's one of the cool things you can do with LaTeX. One, of course, you could do it with Word, but it's kind of different there. So there are some tools, command line tools, that you can give them two different versions of your document, of your LaTeX document, and they will create a diff. I'm gonna try to find one just to show you. Just give me a second, and hopefully I will. Um, no, can't find it here. Well, it doesn't really matter, but there's a way basically where you give it two different text documents, a command, and produces a LaTeX, which is formatted in such a way that you see what is deleted and what is being replaced like. It's like the diff command of LaTeX. Of course, if you're using LaTeX with Git, you also get diffs there. We can actually do that now. So hopefully you all found a way to work with LaTeX locally. Otherwise, I guess you'll have the video you can follow along afterwards. But what we're going to try to do from now on is also add Git in the mix. Okay. So you need to remember where you started the whole project. And in my case, that was temp. Sorry, DC. I'm not even sure what that is. So this is my folder with the text file. Okay. So we have what was it? Oh, that's an old one. Sorry. Yeah. So yeah, you see all the auxiliary files that we said before. Basically, all we know is that there's a text file where we write our code, and there's a PDF which is the output. Anything else is just artifacts from the process created by LaTeX. So there's a log file which has the log, there's a BBL which has some bibliography if necessary, an auxiliary file, something, an individual thing. Syntax.gz, I think this is what links the PDF with the source code for some viewers so you can go from one to another. So it has information for viewers about those things. Doesn't really matter. Let's start doing the same things as we did last time. Let's start a new repository, git init, and then we have it. We were brainstorming with Clara about finding some good analogies about some things. Normally, I've been telling you that a repository is a bucket where you throw the commits in. We thought maybe of a better analogy. So you can think of like when you want to move, you have boxes and you put your things inside boxes, and this boxes goes into a track so that the track goes somewhere else. So you can take this track as the repository, right? And every individual commit is a box inside the track. So when you move, what you do is you take a new box, right? You open it, you assemble it, it's empty, and then you start putting inside what you want to put on the track, right? So that open box is the staging area that we said before, right? So now we want to make our first box and load it onto the track. Clara disagrees? Okay, yeah. Yeah, that should be MNT. That's the question from Guillermo D, and then you should just follow along. I guess that's the question, Guillermo, if you're using Windows Subsystem for Linux. So we have an empty track, and we need to make our first commit. So we need to fill the staging area, which is the open box, with the things that we want. So we're going to use git add to do so, and we're going to add the text document. We get a git status, and that's what it says. It says that the test.txt is going to be added there. Everything else is marked as an untracked files, and that's fine so far. We don't want to add them into the box because the box, we only care about carrying the text file for now. Okay, we are going to do a commit, like first version of our document. Good. So what did we do? We had the open box. We put inside the text file, and then with a commit, we basically closed and sealed the box. We wrote our message on top of that and the information, and then we load it to the track, and the track is the repository. Okay. Yeah, I'm looking at the question from Guillermo. So now if we do git log, just git log, basically, we get that one commit where we have fixed version of our document. Okay. Now you might be asking, if I still do a git status, I'm gonna see that all those things are just ignored, right? They are not in the repository. The track doesn't know of all the other files. It's just here at the mess that we have, our workspace. Now, why don't I add them? So there's one common thing that you should remember about Git, and the idea is that whatever is an artifact or something else, so whatever you can produce for yourself, sorry, whatever you can produce from other files that already are in the repository, you don't need to carry them. I'm afraid we have an issue with Guillermo. Guillermo, there might be an easy solution if you just go to Visual Studio Code and create a new terminal, right? And if that terminal happens to be an Ubuntu terminal over here, that Windows Subsystem for Linux terminal, I think you don't need to care that much about how to go there. Okay. Oh, sorry, I gave you the wrong slashes. Pretty soon. Sorry. So, okay, that is fixed. So, Guillermo, I guess you can see the commands. It's git init to initiate the repository, git add to add the text file, only the text file. Then you could do a git status, then a git commit and everything, right? So, as I was explaining, here we have a bunch of files, right? All the other files, the auxiliary files, the PDF itself, were created by the text file. Therefore, we want to, if you think about it, we want to minimize the amount of files that we put in the repository. Why would we bother tracking the changes of multiple files that are eventually the same, start from the same changes in the first place, right? If I have the text file, I can create all the other ones. Not to mention that maybe my auxiliary files are kind of different for me than for someone else if I use a different configuration and a different set of LaTeX tools and stuff. So those auxiliary files would actually could break, right? You saw before how we had to clean up the auxiliary files for some people in order to make it work. That's probably because moving from one tool to another, the different tools use slightly different configurations of LaTeX, and that could have broken it. So why would I bother share something that not only doesn't add any value, but also can break other things? So I'm interested in only following the absolute basics, and that's the text file. As soon as I give you the text file, you can build it for yourself. There is a small exception for the sake of simplicity, maybe, that maybe for LaTeX documents, you could also share your PDFs. I'm not saying it's a good practice, but I personally do it because it's more convenient sometimes that when someone visits the repository through GitHub, and we're going to see about that soon, they can easily download the PDF without having to download everything and compile it. Anyway, so one thing that we also showed in the previous lectures about Git is that many times this is annoying. I don't always want to be notified about things that are not changed. And I'm getting this yellow color here at the main part, which denotes that there's things in the workspace that could be added to the track eventually, so the repository. And this is annoying. I don't want these files to be constantly there, being notified as track files. I want to ignore them. And we said, if you remember, there's a way to do so by going inside a file, creating a file which is called, that we can name git ignore. And if we do so, we can list the name of files that we want to ignore all the time. So I could say test.aux, test.pdl, etc., etc., etc. Or if I want to have something for all the name files that I can that might be produced, I could do something like this, which eventually means ignore all auxiliary files, ignore all PBL files, and ignore all PLC files, and ignore all log files, and ignore all PDF files, and ignore all syntec.jz. Now notice now if I go back to my terminal, if I do git status, only the git ignore is being an untracked file, so I can add this because this is actually useful, I think, to share. And then I can commit and I can say add git ignore file. I'm going to be a bit fast because we don't have that much time, and I think you can always go back to the video and figure it out. So see now that I'm not being annoyed by the files that I know that I want to ignore, right? I did that myself by seeing the files and listing them here, but I think I showed you before there's another good thing you can do. If you search for GitHub ignore, you'll probably get this, which is a list of well-known ignore files. And what you could do is you could have gotten to deck here. And this is basically a very good example of all the things you want to ignore. So they have made a list of all the files that could possibly be created with all possible configurations. You can just go click at raw so that you actually get the raw file, and then copy everything and paste it in your git ignore file. So that way you're sure that everything is ignored for sure. Now keep in mind whoever made that git ignore, they actually didn't ignore the PDF files. That's up to you if you want to uncomment this file, if you want the PDF file to be part of this thing or not. So you can comment or uncomment the PDFs, but everything else should be ignored. Okay. Yes, log should look like this. Perfect. Yeah, for the git ignore, look for the git ignore repository in GitHub, and or you can just type those things in your. You can make a file called .gitignore, add those things inside, and save it, and then add it and commit, etc. Okay. Now, there's one thing. So I guess by now you know how to commit. You should know how to branch because in theory we saw that before. But we need to see how we actually share that with others because everything we do now is in the track. We load the things in the track, but the obvious purpose of this whole thing is to send the track somewhere else so that others can see our boxes and share them. We don't really send them because we also keep a copy of them, but yeah, you get the gist. So how we do so? We're going to have to learn the push and pull commands. The first thing though we need to do is we're going to have to make another house that is going to host our boxes, right? So because we have our repository here, and we're going to have to send the boxes somewhere, so we need to make them. So we're going to go to github.com. Hopefully you've made an account by now. You should commit and everything. Sorry, login. And if you've done so, you're on some page like this one, I guess. And then we're going to go here at this plus symbol. Yeah, you can send it to the warehouse, class suggest. So what we're going to create now is the warehouse. So the other people can take it from there. Thanks. So let's make this warehouse then. So you press the plus button and a new repository. I hope that was called new warehouse, but it's called a repository. So you're going to have to give a name to your repository. Let's call it LaTeX test, whatever you want that to be. You can put a description here, doesn't really matter. And then you have two options, whether you want this to be public, so whether you want others to have access to the information there, or you want it to be private. As far as I'm concerned, privates are free now in GitHub. They used to be only under a paid option, but they're not anymore, I think. So you can have them for free. So if you do it private, only you can access that, and then you can only add one by one your friends, colleagues, etc., to give them access to that. Otherwise, you make it public and everyone can see. They cannot edit, they cannot send stuff there, they can only download it from there. So don't worry about making it public. Nobody can change things without you giving them permission specifically, but they're going to be able to see your code and everything. I suggest you make this public for now. Maybe it's helpful for debugging stuff in the process. So we made now the repository. Okay, that's the address of the repository, github.com, then it's your username, and then it's the name of the repository. Okay, that's the address of the warehouse. So before we send the track, we need to tell it what's the address of the warehouse. Oh, that's a very good analogy, Clara. So we need to know the address of the warehouse. So we send the track driver there, and this is the address actually. Now we have two options, HTTPS and SSH. You can try either. I would suggest that you go for now with the HTTPS. If you remember your username and password for your GitHub account. If you have enough time, I'm going to show you how to do it with SSH because it's easier and helps more in the long term. Okay, but for now, let's do it with HTTPS. Although I'm not sure if I remember my password account for the account, but anyway. So first thing is we need to set up the address somewhere fixed. Like we said, we need to know the address of the warehouse. We're gonna put it in our local system, and always remember with a name, because we don't, this is the address, right? You don't want to remember this is HTTPS, colon, slash, slash, I don't remember it. So we want to give it a name, because it's easier if you refer to a name instead of the whole address, right? So it's like naming the main warehouse, let's say. Mostly we call we can have multiple ones actually, but we normally have one and we call it origin. That's the de facto name. So, you see, right? Of course. So we need to set up this address, and we do that with the command git remote add and origin, so the name that we want to give, and then you put the address. Oops. Okay, git remote add, then the name that we want to give, some memorable name we want to remember. We normally give it the name origin, and then the URL, so the address of the warehouse. Good. Alles gut. I'm going to press enter, and it's there. Nothing has changed. The only thing that I said is when I say origin, I mean this address. Good. So those things are called remotes. They're just memorable names for addresses. That's all that remotes are. Good. Now, I have one branch, which is called main. It has 2 commits. Let's see the history. Okay, with git log, we have 1 and 2 commits. I could have seen it with the git log graph command. If it's helpful for you, I have this very nice alias. I can show you how to set it up, and it shows the history in a much more concise way, which I personally find quite nice and elegant and informative. So every commit is normally just 1 line, and if I have more complex structures, I can see them more easily than git log graph, but whatever, I can show you how to do that afterwards. So I need those 2 commits to go there in the warehouse. So those 2 boxes, I've loaded them in the track has to go there. How do I do that? I have to say git push. That's all that I'm going to do. I'm going to say git push, and it's going to go there. Well, notice that it says fatal, the current branch main has no upstream branch. That's okay. So when we push, we don't actually send all the boxes there. We send all the boxes of a specific branch there at the warehouse. And because the warehouse is also a repository, it's exactly the same as us. So we have a main branch with 2 commits. It's main, 1 commit, and another commit behind that. When we send those commits there, we just can't send the commits themselves. We need to send them to a new branch there. We still need to name it there. And by default, Git doesn't want to imply the name of the branch. It wants you to specify what is the resulting branch. Okay. Normally we use the same names. My main, I want to be the main on my GitHub repository. Whatever is main for me, I want to be main for everyone. But sometimes it's not this case. So the first time we do so, the first time we push a branch, we need to set up first of all, the address, and second of all, the name of the branch as we want it to be in the destination. So we do that with this -u option, and then we specify which warehouse it has to go and what is going to be the name of the branch in this warehouse. Okay, as we said, we could have multiple warehouses. That's because it's decentralized. If you remember, that's what we said at the beginning. We normally only have one. We have the origin, which is GitHub. Everybody pushes there, and they pull from there. We're going to see that later on. So git push -u origin main. What does this mean? Git push, so push everything I have from the current branch that I am. I'm in main. And please do so in origin and main. Actually, we could have done it without this option, which means do it only once for origin and main. Don't remember anything. If I do so, it's going to ask for my username. And then it's going to ask for my password. That's the one. I hope you remember yours, and it's going to push for yours. Now I'm going to do something for me. Please don't follow along. This is only because I have a different setup. Time. Don't do what I'm doing now, okay? I hope you've made your own GitHub repository. You put the HTTPS as your origin in your local computer, and then you can do git origin, push origin main. Okay, it's going to ask your username and your password in GitHub. For me, it's kind of different, but anyways. Okay, so we did that. Now, notice that if I go back to GitHub, if I refresh, there it is. That's the boxes that we sent there. Actually, it's the content of the latest box that we just see here. If I click here at the commits, I'm going to see the history. So those two boxes that I sent. I have the main branch, and the main branch has two commits. Good. Notice also that if you see the IDs of the commits, they are exactly the same. This one is C26902A, and if I do a git ls1, this is exactly the same, C26902A. Okay. Are there any questions? Hopefully, now you have your own repository in your own account in GitHub, and you have your content there. Jeremy has a... Yeah, so as I said, Git LZ1 doesn't, sorry, my mistake. So as I said, Git LZ1 doesn't exist for you. I can show you how to have this. Sorry, that was stupid of mine. You use git log, okay? Okay, no other questions, so you are either sleeping or I was crystal clear. So that's how you send new things that you've done in the repository. Now, there's one thing that is missing, and that is like assuming that you're working with someone else in the repository, which thankfully for now you don't need to do, right? Until your submission to the first assignment. I think you're all working on by yourself, so you're not going to have anything complicated, right, Clara? But assuming that someone else is also working there, they might push their own things, right? They might push 2 or 3 commits where they have done something. So the next time you open your computer and you go here in the repository, how are you going to take those? Well, there's one command for that, and it's called git pull. Simon, can you send us the output of git status? Is your branch name master instead of main? Then in such case, you could use git push origin master. Right? So every time you push, you need to push at a specific address and at a specific branch. Yeah, sorry, I didn't make it clear before. So you need to send at a specific, sorry, you need to set at a specific address at a specific branch. Okay, so you need to specify that. But if you don't want to do so, because normally you want to have one specific one that you always push, and you want Git to remember that, you can just do a push once, setting this .u that I showed before. And if you push once like that, even if you don't have anything new actually, well, of course, Git doesn't know if you have anything new. It has to still go there and just check. So when I do this once, then I can just git push from now on, and it's gonna work. It's not going to complain because that .u means that I set origin main as my upstream. So that means that my local main is always, 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 unless taught otherwise, going to push to the main branch of the origin. So it's going to go to this address, and it's always going to push on main. So you can do this the first time, and then from that moment on, you can just git push. And as soon as you have done that with the push, you can do the same with the pull. So you can do git pull, and what the system is going to do for you is going to go to GitHub and find that in that address, origin and main. I could have done it like that if I haven't said it before. It's going to go to origin, it's going to look for the main branch, and it's going to say, okay, that branch, does it have anything new compared to my main? Well, in that case, it doesn't. So that's why it says already up to date. We don't have, okay, perfect. Clara suggests that I add her to my repository so she can push some things and we can demonstrate how it's going to work with someone else pushing and then me needing to pull. So I'm going to add Clara here as a collaborator. So this is the GitHub environment. You have to go to settings. If you want to give access to someone, you're going to have to go to manage access, and you're going to have to press to invite the collaborator, find them, and then select that collaborator and then send them an invitation. They will get an email and they will have to accept the invitation. So from that moment on, they have access to your repository. So that person can push your repository. Everybody can pull from your repository since you made it public, if you made it public. So everybody can download commits, but no one can push this unless you give them specifically access. Okay. So Clara, hopefully you will add something. Let us know when that happens. Meanwhile, okay, Clara is working on this. Are there any questions? Before we go quickly, please type any questions when you have. Well, we have 20 minutes, so that's good enough. I'm going to go through some Git stuff in the meantime and show you some other things that you can do. We don't really have that much time to do them now, but still it's good to know them. So remember that begin and end that we showed before? That's for the document. We begin the document environment, we end the document environment. You can use them for cases like when you want to have bullets or numbering. So you can create the itemized environment and end it somewhere. And in between, you can just add the items. So you add tea, milk, and biscuits, and then those are going to be printed in the PDF as individual bullets, right? Since we have some time, I just realized, let's just try this out. I'm gonna close this. I'm gonna go here somewhere and add the bullets. Well, in those small environments, it's good to keep an indentation. Personally, I prefer so. So Close that. I'm going to save the document. Visual Studio Code is amazing and it's going to build it for me. So you see, I initiate the itemized environment. I start listing the items. And then when I'm done with this bullet list, I just edit. Again, this is a good demonstration of how I just focus on the content and I have more control over some things that I do. Because I don't know if you've noticed, but sometimes when you work with Word, it's kind of vague when this environment stops. I mean, when you press enter, you're going to get another bullet, and then you're going to have to press backspace, and it's like there is an indentation, but normally not a bullet. So it works kind of weird. While in this case, I have full control over when my bullets are starting, when they end, and what are they, right? If you get used to those things, it might feel at the beginning that it's kind of like writing too many things for something as simple as just having bullets. But I think in the long term, knowing those things actually helps a lot. Now, how do you include images? You have another environment which is called figure. And that's actually kind of a cool thing because figures include a bunch of things like the image itself, the legend, captions, and all those things. And you use this command, which is called include graphics, and you link to a specific PNG or JPEG or PDF. And that way you include your graphics. You need to add a package as well. You can have the equation environment where you can have, well, basically equations, and it's going to do the numbering for you because, well, LaTeX is pretty good about math and stuff. You can do inline equations as well by using the dollar symbol. Maybe I could show you that. For instance, if I start with dollar, I say A equals B plus C. And you will notice how the styling of this is going to be this mathematical thingy, you see? Like styling is this, it's a different font and it's italics and everything. And you can use Greek letters like alpha equals beta plus gamma. And that way you'll get Greek letters. By the way, if you're Greek and you want to do LaTeX in Greek, it's not that easy, sorry. I had it in my master thesis. But yeah, but for simple equations, you can use this alpha, beta, gamma, etc. Okay, so Clara did something for us. So she added a new commit. So I'm going to go here. I'm going to do git status. I've changed some things. And well, let's avoid any conflict for now. It's going to be weird. So I'm going to undo everything. There's actually a better way to undo, but I don't want to make it more complicated for you guys. So I'm going to go back, git status. There's nothing new. Sorry, git status, there's nothing new. And if I go to GitHub and I refresh, I see that Clara actually has been the latest author here. If I go to commits, I see her commit here. I can go to the commit, see what she changed actually, which is pretty cool. So she added a simple image file and the tag itself, just to change the authors. So I'm gonna go back and I'm gonna do git pull. I'm not sure if it's gonna ask for your username and password. In my case, because I have slightly different configuration, it asked me for a password and I get that. Well, a bunch of complicated stuff, enumerating objects, we don't care that much. What's kind of interesting is that it says that from LibreOptional's LaTeX test, so the warehouse that I have, I took main, it took origin main, and main is now at the same point as origin main. Okay, well, doesn't matter that much. If you might get a conflict here, that's the most confusing part. In that case, we didn't. And if I actually do a git log graph, here it is. Clara Garcia San. Clara, your name is not. And there it is, her changes. If I go back to Visual Studio Code, well, there it is. I have the different authors that she made. And if I check my files, I also have the JPEG that she added. So if I save, actually it's built already. Okay, so I get John Doe and Silvia Vitalis and Clara Garcia Sanchez. Good. So we push when you have something new, we pull when someone else has added something new. Right? Are there any questions so far? No? That was crystal clear. Best Git course ever. One last thing. When you push, you can only push if the current place that you are is the latest. How should I say that in a sense? Yeah, you can push as soon as you have already what is in the branch that you're going to push. So what I mean by that is, if I've made a change before pulling Clara's change, and I try to push that one, Git wouldn't allow me to do so. And that is because basically Clara made a new branch in theory, right? If you think about that, if I'm here and I start working at something and I make another commit, I have another commit there, okay? Meanwhile, Clara added another commit there. We started from the same thing, but we made two different branches. It doesn't matter that they're both called main and they're in different warehouses. I have a different idea of what main is compared to Clara. And I cannot push unless Clara's commit is back in history compared to my main, right? So it might be the case that if you do something and you haven't gotten changes from others before, then you're going to have, it's not going to allow you to push. In that case, you need to pull first. And when that has happened, like a diversion because someone else did something simultaneously with you, Git is going to be clever enough to do a merge in that case and basically merge the changes that me and Clara in that case made in one commit, and then you can push that commit. Okay, so if you remember, we learned about how to do branches and how to do merge. It's kind of complicated as far as I can say. I understand it's not necessarily that easy to understand, but nevertheless, what basically a git pull is a fetch. So it downloads this thing and then merge. So it's going to download whatever new thing is there and it's going to merge it with my current branch. So in that case, my branch was here. So what it did, it downloaded that one and it merged it with my previous branch. That was straightforward because it was only one commit ahead, so it just moved it forward. I think we saw that example where you can have just a branch which is only one or two or three commits ahead, and then all you have to do is just take the other branch and move it forward. But anyways, yeah, that's the deal. So if you try to push and it doesn't work, you have to pull. Hopefully you don't get any conflicts. We saw how you deal with conflicts anyway. And if you have any conflicts, you have to fix them, you have to commit, and then you push. Okay, it's all a bit complicated. You can only get it if you practice on top of that. And yeah, that's pretty much the whole gist. So I think that should be enough. If you have any questions, make them. Otherwise, let's go quickly to some other things you can easily do with LaTeX before we close the session. So I showed you how you can do inline equations with a dollar, or how you can do equations on their own with the equation environment. So I can say begin equation and equation. And then again, I can have alpha equals beta plus gamma. And if I save that, okay, something wrong with that. Guess I had to compile it by hand. And I get the equation here, like a big equation with its numbering and everything. Right? So when you have equations, you can do things such as using this symbol and that symbol, so the caret and the underscore, to define superscript and subscript. Right? So if I want to say, let's do an inline because I think it's better. So if I want to say alpha at the power of 2, I'm using the caret symbol, and I save that. Just the code is a bit weird sometimes. If I build that, I get this. Right? If I want to say alpha 1, A1, actually, in that case, you use the underscore symbol. Again, you can say, I can build. See how I get the subscript when it has to compile a few times? And I get this thing. And if I have more complicated things, such as if I have a subscript or superscript that is like maybe a small equation or something, I can use the curly brackets to do it. So if I had a n plus 1, I can use the curly bracket to denote that this is the whole subscript. Otherwise, it's going to take only the first character, right? It's going to think this is a of n plus 1. So the difference is if I save that and I compile. Yeah, you can use Text Studio, as I said. Maybe it's easier for you when you start. Or you can use TextWork. You can experiment with different editors. So you see how it thought that plus 1 goes to the whole n, while if I wanted n plus 1 to be the subscript, I should have used the curly brackets to do so. So especially if you have equations, LaTeX is a lifesaver, I think, because you basically learn all those basic notations and all those things that you had to do with buttons and annoying stuff in Word, you can do them with this symbology. Yeah, the Greek letters we showed, and well, you can have tables, but that's, yeah, I have to, yeah. Tables are not that easy. Again, you have to start an environment, which is basically a tabular environment. And I'm not going to go too much into it, just a simple example, tabular and tabular. And then basically you need to define what kind of columns you have, and you set up the alignment of every column. So let's say I want to have one column that is left aligned and another one that is right aligned and another one that's also right aligned. And then every line you just write it on its own line. So I can say A, you divide the columns by the ampersand symbol, I don't remember how it's called, and one, one, and then at the end of every line, you just put the two backslashes. And then again, that's the second line, and then another one. So if I print that one, I'll get a table of this form. Now notice how there are lines missing, so there are no lines. So there are two kinds of lines. There are the vertical ones and the horizontal ones. The vertical ones are quite easy. You just add this symbol, which is normally over the return. It's like the vertical line between the columns. And if you do so, you will get the vertical lines. So in that case, it should get for every column a vertical line as such. And if you want horizontal lines, you have to do it for every individual row, which kind of sucks, but it is the way it is, and I get no complaints for that. So you have to specify the horizontal line, let's say at the beginning, and maybe you want to do it here as well. I think it's, yeah, after the two lines, or with the two lines, doesn't really matter. So if I do that now, I'm going to get only for the first two lines a horizontal line, the first two rows. I think I know what Anna is going to write. There's an online tool which can build the code for you. Oh, no, okay. Yeah, perfect. So one last thing. Um, so you remember how we saw before that you got this prompt, some of you, to install some things? And well, those are called packages. So what we basically just saw is the basic functionality of LaTeX. But in order to do some more complicated stuff, you can use packages. And there are packages for many cool stuff. For instance, there's a package where you can just very easily just define concepts like graphs, and it's going to build them for you. So if you remember the graphs that we saw, all the graphs where I saw the history of commits and stuff, that was done with LaTeX. And all I had to do is give the names of the commits, and with some symbology of dashes and stuff, I would just define that, and PDF would make the whole boxes and then the trees for me. And also in this presentation itself, this and that is made entirely in LaTeX. I posted the source code of this presentation before, so you can go and look at it. And all those things can be done with packages. So in order to use a package, you need to use a use package command, and you do that at the preamble. So if you remember what we said before, the preamble is everything before the begin document place. Okay, so if I want to use a package, I find the package and I use the use package command, and I would put say dixet. There are many packages there. The most typical one is graphics, sorry, something like that. I don't remember now. Even those, we normally also look them up. And then you can include the package there, and then you can use the command whatever they are. There are like tons of packages for things to do, like having abbreviations where you can set up the abbreviations in the preamble, and then you just refer to them in your text with a specific code, and then the system is going to build the preamble for you. Well, for bibliography, there are some packages, and there are packages for doing the table of contents and stuff. All those things will be done automatically for you based on sections, subsections. You can have packages for having the list of figures, etc. So you have to look them up, all those things. Um, another quick thing is that you can have cross-referencing. So when you have a section or a figure or something, you can use the label thing, and that way this is a code way of referring to that. So you saw how section one was given a number one, section two was given a number two. When you want to refer to another section, you want to see in section two, you don't really have to type two, right? It's better if you just refer to that section. So if you add something before the numbering changes, then the reference also changes as well. So you can label something with this, and then you can refer to that with the ref command, right? So in that case, for instance, we had the section which is called method, and we label it as sec colon method. That's just a name. It could be called just method, meth, whatever. Well, not meth. And then you can refer to that like this. And that means that here, LaTeX is going to replace that with the number of the specific section. Or you can do that even in an equation. You saw before how we can have the environment of an equation. We can label the equation and we can refer to that with the eqref command. And actually, this is a command that is not coming pre-installed, and you have to actually use a package. So in that case, this is AMS math. This is also quite famous package. So all those things you have to look them up and kind of play with them. So I'm going to finish by talking about references, and that's actually where LaTeX shines. So the good thing about LaTeX is that you can have all your references in the file, which is having a suffix.bib. And normally when you do a literature review somewhere, you, like in Scopus or even in Google Scholar, although it's discouraged to use it, you can find the BibTeX entry. So a BibTeX entry is a way to describe in this weird language the information of a reference. So the author, the title, journal, the year, etc. So instead of having to create those individual bibliographies yourself or typing them out at the end of your thesis or your article or something, you put them once in a .bib file. And then from inside your article, you can refer to them by using the navbib package, for instance, and those two commands, the cite t and the cite p. The cite t actually refers to something as it's part of a text itself, like part of the sentence, and cite p is going to put it in its own parentheses at the end of a reference. Okay, so this is super cool, and then at the end it's going to create the references for you. I'm not sure, you cannot see it probably, but for instance, in that case, because I cited something, at the end I just asked for LaTeX to print the bibliography for me, and it's going to find out only the articles that I've referred from the bib file. So I can have a bib file with all the bibliography ever found. If I cite only 3 papers, then the references part at the end is going to give me only those 3, which is super cool. And you can easily swap the styles. So there are different styles according to where you want to submit. And you can easily switch. So the ways where you can refer with numbers and the numbers are at the end of the references and stuff, all those things are being handled for you. And it's at that point is where LaTeX actually pays off the most, especially when you do your thesis at the end. We provide you with a template. You don't have to build all those things from the beginning. You don't have to define the class and everything. You will get some basic text file to work. And all you have to do is start adding BibTeX entries in the bib file, which you can find by your literature review that we'll be doing at that point, and the citations. And you'll see that it's going to save you a lot of time. Now, this bib file, you can either edit it with a text editor and just find the BibTeX entry somewhere in Scopus or Google Scholar or whatever and copy paste it. Or you can use some tools like Jabref, I don't know how it's called exactly, how to pronounce it exactly. I'm using that, for instance. And this is a very interesting interface. Maybe I can show you a bit. Where you have all your references and then you can easily cite them. It takes a while to load. And if it wants to load, I'm going to show you how it is. So this is how it is. So this is the content of a bib file, and those are all the um, entries that I have, and I can use easily those references in my LaTeX document. That's pretty much it. For the images, you have to make them yourself. You have to make either PNGs, or you can use PDF vector files as a way to have images. I showed the command before. Yeah, those are some templates. That's for the end. So I'm gonna give you these exercise if you want to do it. So I hope those links still work. So you could start working on that file, and this is how it should look like. So I will give you a very messed up LaTeX file, and you have to make it work like this. There are things you have to fix. You want to play? You might want to play with it. Let me show you the code as well. Come on. So this is the messed up version, and you have to make it look like this. In theory, by following what I showed you with the presentation, you should be able to do so. It's a good exercise to do, and we're always here to assist you, as we didn't have enough time to go through that during the course. And those are some links. This is the link to these slides, but you have this already. And this is a very interesting link where basically you can find all the basic stuff that you want to do. So Wikibooks, LaTeX, and there's so many ways about how to do tables, special characters, of course, as you see, I've visited many times, how you can do formatting here and there. It's very interesting, and you learn a lot of things. So we went a bit over time, but I guess that was kind of necessary. If you have any questions, let us know. I guess everybody left. Yeah, and Sana notice Yabref is kind of a stable, so make sure that you save often when you use it. Questions? Oh, okay, I didn't know that you could use Overleaf with your TDOs. Okay. Well, the only downside of Overleaf is that you cannot use it that easily with external files. It's kind of annoying. And also, well, Overleaf has a funny thing where you can actually directly push and pull through Overleaf. It's super cool, but it's not straightforward. So, well, in theory, you can do things in Overleaf, then pull them and then push them, but it's something complicated for you at this point, I think. So I think that's all from me now. You either left or, yeah, you don't have any questions, I guess. So, Clara, we agreed that we're going to have a session on Wednesday for assistance with anything that you might need, Git, Python, LaTeX, um, or yeah, the statistics that you do with Clara. So not sure if we have time or anything for now. Uh, yeah. Well, so then I'll see you then, I guess. It was fun that you saw me because I didn't see you. But yeah, well, maybe yeah, on Wednesday we could do it. Maybe you're in place. I don't know. Maybe I could make it this Wednesday. That could be fun actually. So yeah, that's it from me. Thanks for having me. Okay. See you around, guys. Bye.